Okay, good morning class. So today we're looking at exponential and log functions. We're at exercise 3. And exercise 3 is on page 54. So here we are told that for each graph in question 1.1 to 1.4, draw the graph of f of x using a table of key features of the exponential function. Indicate the coordinates of 3 points on the graph of f and label f clearly. Use your graph of f of x and draw the inverse, which is f to the minus 1 of x. Indicate the coordinates of the 3 points on the graph of the inverse function and label the inverse function clearly. Draw the line of symmetry about which f of x and the inverse are symmetrical. Write down the equation of the inverse function. Write down the range and the domain of the function and its inverse. State whether f of x and its inverse are increasing or decreasing functions. So let's go with the first one. Okay, so the first question was, okay, so what was the first question? Sorry? Draw the graph. So the first thing we draw is the table. Okay? It's an x and a 1. There's minus 1, 0 and 1. So it's a quarter, 1 and 4. So let's draw. Let's put a line here for now. Your y and your x. So if x is minus 1, okay, by minus 1, 0 and 1, minus 1 and a quarter, minus 1 and a quarter, 0 and 1, and 1 and 4. Okay, so the graph comes close to the x-axis, doesn't touch, and here we go. It's a graph of B. What's the B part of the question? Inverse function. So what do? We interchange x and y. Why are you not saying? So the three coordinates that they asked was those three. So the inverse function. So what do? We interchange x and y. So negative 1 and a quarter becomes quarter and negative 1. Okay, so that's a quarter and negative 1. 0 and 1 becomes 1 and 0. 1 and 4 becomes 4 and 1. So again, the x-axis was the asymptote, now the y-axis is the asymptote. Okay, the graph isn't go through that point there. So let's do it a bit closer. And there we go. Then I ask you to draw in the line, the symmetrical line, which is in this case y equals. Right, what's C? Is it C the symmetrical line?
Yes,
right, D.
Write the equation of the inverse f of x in the form y is equal.
Okay. So what do we do for the inverse function? It's not D, no? What do you do for the inverse function? Interchange x and y. Remember, that's a y. So x is equal to 4 to the y. Make y the subject of the formula. Y is equal to log x base. This is the inverse. People, is the inverse a function? Yes. Why? Pass the vertical line. Let's look at E. What is E?
E is right on the range of f of x and
The range and domain.
yes, and the domain of the
Inverse function. Okay, so domain and the range. So the domain of the function, which is f of x, as you can see, is going negative infinity, positive infinity. So x is an element of all real numbers. Let's look at the range. Does this graph exist at negative infinity? Where does it start existing at? 0 onwards. So y is greater than or equal to? No, not equal. Why not equal to 0? Asymptote. And we see the domain become the range. So for the domain is x is greater than 0, as you can see, which is true. And your range is y is an element of R. Is there an if? What's the question if? Okay, what is? So we're looking at f of x. Is f increasing or decreasing? Increasing. And its inverse? Increasing or decreasing? Okay, so for your exponential and log graphs, if the one increases, its inverse will increase as well. Okay, is there any confusion there? Okay. Let's look at 1.2. So where do we start? We start by drawing the graph. Not so. Go over the table, so it's a x and y. Negative 1, 0 and 1, which gives you 4, 1 and a quarter. Let's draw. X 0, 1, 2, 3, 4. Okay, so by negative 1 and 4, negative 1 and 4, 0 and 1, 1 and a quarter. So again, it's the asymptote, the graph comes close, but does not touch. Here's the graph of. And then we will look at the graph of the inverse function. So 1 and a quarter becomes a quarter and 1. 1 and 0 becomes 0 and 1. And negative 1 and 4 becomes 4 and negative 1. Again, the x asymptote becomes the y asymptote. And this is the equation of the inverse function. And that's the graph of the inverse function. Then they ask you to draw in the axis of symmetry, which is the y is equal to x line. Make sure it's going through the point of contact. Okay? So that is B, C. So answer no? D. They ask you to work out the equation of the inverse function. Not so. So what do we do for the inverse function? We interchange x and y. So remember that's a y. Yeah? So we can say x is equal to a quarter to the y. So y is equal to log x base a quarter. Or is equal to negative log x base 4. One of the two. Again, I showed you quite a few times already how to get that thing. E, the domain and the range. So domain of function, x is an element of R, range, y is to be greater than 0. We know for the inverse functions interchange. So y is an element of R, as you can see here. The graph is going negative infinity, positive infinity. This is the inverse function now. No? All the values of y exist. And your domain, x is greater than 0, which is the inverse of the which is at the base. Okay. F. What's the question in F? This graph increasing or decreasing? Yes? Decreasing. In both cases, no? Okay. Any confusion there? Get 1.5, 1.3 and 1.4, 1.3. 8. I'm going to draw the graph again using the table. It's the same thing happens all the time, just different numbers. Okay, so if we draw, so negative 1 gives you 1 over 5, 0 gives you 1 and 1 gives you 5. Negative 1 gives you 1 over 5, 0 gives you 1, 1 gives you 5. Here the graph comes close but doesn't touch. There is that graph. This is the graph of F. In the B part, we are told to draw the inverse function. So you interchange x and y. So 1 and 5 becomes 5 and 1. 1 and 0 become 0 and 1 becomes 1 and 0. Negative 1 and a fifth becomes a fifth and negative 1. Very close to the x-axis, okay? Again, the graph comes close but doesn't touch the axis. And that's the equation of the inverse. Is the inverse a function? Yes. Passes the vertical line test. And then for C, they ask you to draw in the axial symmetry, which is x is equal to y. And this was the answer to B. C, the question was, sorry, D, the inverse function. What do you do for the inverse function? We change x and y. So x is equal to 5 to the y. So y is equal to log x base 5. Remember the base remains the base. Okay, so f to the minus 1 of x. For those of you who are confused, we change it from log and from exponential to log. The exponent will be the subject of the formula, so x is equal to log y y base. It's changing it from log from exponent to log or log to exponent. E, the question was again the main and range. The main of the function, the range of the function. As you can see, for the function, it's going negative infinity, positive infinity. So x is an element of R. Look at the range. Does this range exist at negative infinity? No. Where it starts existing at? 0 onwards. So y is greater than 0. Let's look at the domain of the inverse function and the range of the inverse function. As you can see, does this graph exist at negative infinity? The inverse function on your x? No. Where it starts existing at? 0 onwards. So x is greater than 0. Does this graph exist at negative infinity? Yes. Positive infinity? Yes. That's going up, goes all the way to infinity. So, Y is an element of order. As you can see, again is the interchanging. F, is this graph increasing or decreasing? Because as x increases, this graph is increasing. So f and its inverse is increasing. Okay. So the next one. Look at 1.4. So we start off with drawing the graph. Start to begin with the table. It's a x and a y. Negative 1, 0 and 1. So it's going to be 2, 1 and a half. Okay, y, x. Okay. So minus 1 and 2, 0 and 1, and a half, and 1, sorry, 1 and half. Graph is decreasing. Okay, and this is your function. For your inverse function, we interchange x and y. For the B part of the question now. So negative 1 and 2 becomes 2 and negative 1. Okay, 0 and 1 becomes 1 and 0. And negative 1 and 2, we got that. And then we got 1 and a half becomes half and 1. Graph comes close, it doesn't touch. That is your inverse function. This is the B question. Then they ask you to draw in the line of symmetry, which is y is equal to x. Okay, that's your answer to C. D. What's the question for D? The inverse function. What do we do for inverse function? Interchange x and y. Remember, this is a y. So x is equal to log jumping the gun. So it's going to be x is equal to after the 1. So therefore y is equal to log x base half, or y is equal to negative log x base. This is of course the inverse function. Either or, no? E, the domain, the range. As you can see, this graph is going to negative infinity, positive infinity. It's all the values for x exist on the graph. So x is an element of all real numbers. The range. So this graph, the f of x graph, exists at negative infinity? No. Where does it start existing at? 0 onwards. So y is greater than 0. The domain and for the inverse function we interchange, of course. So the domain of the inverse and the range of the inverse. So the range now becomes y is an element of R. As you can see, graph goes positive infinity, negative infinity. And we say now x is greater than 0. As you can see, the domain of the inverse function is more than 0. This is an increasing or decreasing graph. As x increases, the graph is decreasing, so it's decreasing. Both is decreasing. Alright, any confusion there? And I say that this is not part of it, but I'll just do one of it, just to give you an idea of what's happening. In question 2, I says repeat questions 1a to f for the exponential graph of the form y is equal to x plus a to the x plus 2. Remember that the horizontal asymptote for these graphs is y is equal to 2. People, if we draw this graph, where do we start? We start with a table. Which values you put in our table? -1, 0 and 1. So put -1, I get 1.5. 0 gets 2, 1 gets 3. Enough information to draw the graph. Remember, where do we start? We always start with the horizontal asymptote. So it's 1, 2, 3, 4. The horizontal asymptote here is y is equal to 1. Okay. So we go -1, sorry, 1, 2, 3. 1, 2, 3. Okay. So -1 gives us 1.5. So that's now 2 now. So this is -1 and 1.5, or 3 over 2. And then 0 gave you 2, and then 1 gives you 3. So as you can see, the graph comes close, but does not touch. So that is your f of x graph. So what do we do now? Now we look for the inverse function for b. So the horizontal asymptote, which is y is equal to 1, becomes a vertical asymptote at x is equal to 1. That is it. So minus 1 and 1.5 becomes 1.5 and minus 1, which is there. 1.5 and minus 1. This is 0 and 2 becomes 2 and 0, which is that point there. And then 1 and 3 becomes 3 and 1, which is here. So the graph comes close but doesn't touch. So we go through like that. Okay. So this point here is actually on this line, on this asymptote. As you can see, it's on the asymptote of the inverse function. That's on the asymptote of the function. Okay. Now this graph is reflected in the line. Y is equal to x. So this is the answer to B. That's the answer to C. Okay. Let's look at D. What's the question in D? Sorry, the equation of the inverse function. What do you do for the inverse? We interchange x and y. That's the y. So we say x is equal to 2 to the y plus 1. Make y the subject. We'll make that term the subject of the formula. So y 2 to the y is equal to x minus 1. Remember, we want it in the form of b is equal to a to the x. That's the form we wanted. That is not in that form. Can you see? We need that on its own first. Then we change it to log form, which x is equal to log b base a. The exponent will be the subject, so therefore y is equal to log x minus 1 base 2. And this is the inverse. Is this inverse a function? Why? What's the vertical line is? What type of function is it? 1 to 1. Okay, for every 1x is 1. 1. Here, let's look at E. E is the domain and the range. And the domain of the inverse function and the range of the inverse function. Okay. So as you can see, this graph is going to negative infinity, not so, and positive infinity. So for the domain, x is an element of R. Let's look at this graph. Does this graph exist at negative infinity? Where does it start existing at? 1 onwards. So we say y is greater than. Let's look at the domain of the inverse function. This is the inverse function. Does this graph exist at negative infinity? No. Where does it start existing at? 1 onwards. So x is greater than 1. Let's look at the range. Negative infinity, positive infinity. So y is an element of all real numbers. Let's look at f. Is this graph increasing or decreasing? Huh? And this one here? So both is increasing. Alright. Any confusion there? So that brings us to the end of exercise 3.